Hello everyone. Today in this video we are going to discuss on the topic System of Linear Equations, and I am Ms.R.RAMYA, Assistant Professor, Department of Mathematics from SA Engineering College. System of linear equation. This video, it is just going to be an introduction on this topic. Before moving on into the problems, let us discuss few important concepts, basic ideas on this topic. Linear equation. When an equation is said to be a linear equation, we might have come across many equations. Among all those, an equation in which the power of all the variables are just one only, then such equations are said to be linear equations. For example, I have considered three equations here. When we check, the power of all the variables x, y and z are just 1. That is why all those three equations are said to be linear equations. When we check these values, x is equal to 2, y is equal to 1 and z is equal to 0 becomes the solution for this equation, which means it satisfies this equation. See, when we put 4 into 2 plus 2 into 1 minus 0, we get the answer RHS, which is 10. We could also see that another set of values also satisfy the same equation. X is equal to 1, y is equal to 4 and z is equal to 2. See, when we substitute all these values for the same equation, these values also satisfy the same equation. Which means it is not necessary that linear equation should possess only one solution. It may also have many other solutions also. Now, our actual aim is on system of linear equations. What is said to be a system of linear equation? A collection of linear equations, collectively two or more equations put together with same set of variables which has common solution. Say for example, I have considered three equations here. For this system, the variables are same x, y, z, and it should be true at the same time all those equations separately. So for this system, the solution is x is equal to minus 2, y is equal to minus 1 and z is equal to 3. When we substitute all those values, all those three equations should satisfy the condition. This shall also be extended up to n variables and m equations, where all those a's are nothing but coefficients and all those x are nothing but variables and all those b's are nothing but constants. Solution for the above system of equation be S1, S2, etc. up to Sn, which means this solution S1 to Sn should satisfy all the equations given in the system. How the system of linear equations classified into? This system also has a classification. How it is classified? This system of linear equation is classified into homogeneous and non-homogeneous. When we check, in the system, all BI's are 0. If all BI's are 0, then it comes under homogeneous. If any one BI is non-zero, then it comes under non-homogeneous. Say for example, I have considered three equations. When we check the homogeneous, for this system homogeneous, all the RHS are 0, all BI's are 0. Whereas for non-homogeneous, the first equation, for the first equation, BI for the first equation is non-zero, which means it falls under non-homogeneous. So the condition for homogeneous is that all BI's should be 0. How this system of linear equation be represented in the matrix form? This system shall also be represented in the matrix form. Let us see how it is represented. The system of linear equation shall be represented as the product of the matrices AX is equal to B, where A is nothing but the coefficient matrix and capital X, the matrix capital X is nothing but column matrix with all the variables, and B, the matrix B is nothing but the constant, all those constant Bi's. How to identify whether the given system of linear equations have solutions or not? So, when we consider the system, it may have solution, may not have solution. How to identify it? For that, we consider augmented matrix. Augmented matrix is nothing but enlarged matrix, enlarging the actual matrix A, combining another matrix B with that. So this set of values belongs to the matrix A and this values belongs to the matrix B. So augmented matrix AB. We find the rank of the matrix A and then we find the rank of the matrix AB. Rank is represented as row of A and row of AB. So row of A, if row of A is equal to row of AB, that is, if the rank of the matrix A and the rank of the matrix augmented matrix AB are same, and with that rank is equal to n, if the rank is equal to n, then we say that the equations are consistent. The given equations are in a proper way to give solution. In that case, we have unique solutions. Whereas, if the rank of A is equal to rank of AB, such that the rank is less than n, where n is nothing but total number of variables. I said that previously, capital X represents the matrix, variable matrix, where we have n variables. So n represents total number of variables. So if the rank of A is equal to rank of AB and if that rank is less than n, then in that case we say that the system has infinitely many solutions. Even in that case also equations are consistent, it is in a regular form, but it has infinitely many solutions. Whereas if rank of A is not equal to rank of AB, if both the ranks are unequal, then in that case there is no solution at all. This shall be represented graphically like this. We know that linear equation is nothing but a straight line, where if two straight lines meet, in that case there is a solution. Whereas if two lines coincide, in that case there are many solutions on all the points on the line. If two lines are parallel, they don't meet at all. In that case, there is no solution at all. So, row of A is nothing but rank of the matrix and rank is nothing but largest order of the non-zero minor of the matrix, or just simply number of non-zero rows in row echelon form. This row echelon form is nothing but upper triangular matrix, converting the actual given matrix into upper triangular matrix. And for any non-singular matrix, that is for any matrix whose determinant is not equal to 0, in that case rank of that matrix is given by the number of variables n. Now, how to solve the system of linear equation? We do have various methods to solve system of linear equation, and few methods are given by Cramer's rule, inverse method, Gauss-Jordan method, Gauss elimination method, linear decomposition method. But 99% in GATE exam point of view, finding the solution of the system is not going to be the question. The interest is not in finding the solution of the system of linear equation. Questions will be asked in the form of whether the given system has solution or not. If solution exists, how many solutions are there? Whether unique solution or many number of solutions. In that type of questions alone will be asked in GATE exam. Now let us move on to problems. So here it is given that consider the system of linear equation x minus 2y plus 3z is equal to minus 1, x minus 3y plus 4z is equal to 1, minus 2x plus 4y minus 6z is equal to k. The value of k for which the system has infinitely many solutions is, which means we need to find the value of k such that this given system has infinitely many solutions. And the condition for infinitely many any solution is given by. Row of A is equal to row of A comma B, which should be less than n. The condition for the system to have infinitely many solutions is rank of A is equal to rank of AB, which should be less than n. And here n represents number of variables, and here we have 3 variables, so n is equal to 3 here. In that case, rank of A should be equal to rank of AB, and this should be equal to 2. Row of A is equal to row of AB, which is equal to 2. It should be equal to 2. Less than n, less than 3, so it should be equal to 2. And so we need rank of A and rank of AB, and we find rank through row echelon form. So considering the augmented matrix now, augmented matrix A comma B is given by 1 minus 2, 3 minus 1, 1 minus 3, 4, 1 minus 2, 4 minus 6, and then K. This becomes the augmented matrix where these values represent the coefficient of all the variables x, y, z, and these values represent the constants which are given in the RHS. Now we have to convert this matrix, augmented matrix, into row echelon form. For that we have to convert this and this element as 0. In that, first we are going to convert this element as 0. So this is R1 and this is R2 and this is R3. Now R1 as it is. R1 as it is. 1 minus 2, 3 minus 1 as it is. Minus 1 as it is. Now I have to convert this R2, this element, to 0 using R1. So R2 becomes R2 minus R1. So 1 minus 1 is 0, minus 3, minus of minus 2 is minus 1, and then 4 minus 3 is 1, 1 minus of minus 1 is 2. And next case, I am going to convert this element as 0, minus 2. Here we have minus 2. Only if I convert this element as plus 2, it is possible to convert by adding those two elements to 0. So here we have 1. So we have to convert this as plus 2 using this R1 element 1. This is R1. And here it should be the term we have to multiply such that it becomes plus 2. So multiplying 2 here. So R3 becomes R3 plus 2R1. R3 plus 2R1. The first element is minus 2 plus 2 into first element 1, which is 0. Second element 4 plus 2 into R1, which is minus 2, which is 0. Third element minus 6 plus 2 into 3, which is again 0, minus 6 plus 6, which is again 0. And the last element, which is K plus 2 into, we have minus 1 over here, minus 1, which is equal to K minus 2. Just replacing all those values over here. 0, 0, 0, and this last element becomes K minus 2. Our aim is to convert into row echelon form, and we have obtained it. We have already converted all those 3 elements into 0. Now it is over. Now finding rank of the matrix A and then rank of the complete augmented matrix. When we check, rank of the matrix A is 2. Row of A is equal to 2. So from this row echelon form, row of A is equal to 2. Our aim is to check whether row of AB is also equals to 2. Only then we get infinitely many solution, right? To get that, it should be equal to 0. This element should be equal to 0. Only then row of AB completely becomes 2. That is only if k minus 2 is equal to 0. If k minus 2 becomes 0, already row of A is equal to 2. Only if k minus 2 is equal to 0, we get row of AB. Row of AB is equal to 2. So in that case, it satisfies this condition. Row of A is equal to 2, row of AB is also equals to 2, and they are less than the number of variable 3, which means it has infinitely many solutions. So k minus 2 is equal to 0. K minus 2 is equal to 0, which means k is equal to 2. Only if we consider the value of k as 2, this value becomes 0, and overall rank of A and rank of AB becomes 2, which is less than the number of variable 3. So the solution for this is, our aim is to find the value of k such that the system has infinitely many solutions. So which means the value of k is equal to 2. Now let us move on to the next problem, where the question is, consider the system of linear equation Ax is equal to b, where A is given by 1 minus root 2 3 minus 1 root 2 minus 3, and the matrix B is given by 1 and 3. So Ax is equal to b, and the question is to find this system of equation admits unique solution, infinitely many solutions, no solution, exactly 2 solution. So whenever to check whether the system has a solution or not, or the number of solutions, we need augmented matrix, and we have to convert that augmented matrix into row echelon form. That is the concept, right? Now here capital X is not mentioned. Now considering that capital X as X and Y. Now this system Ax is equal to b, Ax is equal to b becomes x minus root 2y plus 3z is equal to 1, and minus x plus root 2y minus 3z is equal to 3. Now when we consider this second equation shall be written as, taking minus as common outside. If we take minus as common outside, it becomes x minus root 2y plus 3z is equal to minus 3. Is equal to minus 3. Whereas the first equation, considering the first equation as it is, x minus root 2y plus 3z is equal to 1. When we check these two equations, it is very clear that these two equations are parallel lines. Parallel lines. And as I said, as these two are parallel lines, they do not intersect at all, which means there is no solution at all. So this is the correct answer. There is no solution for x, as these two are parallel lines. So this is the answer for this question. Now let us move on to the next question. The system of equations x plus y plus z is equal to 6, x plus 4y plus 6z is equal to 20, x plus 4y plus lambda z is equal to mu has no solution for values of lambda and mu, which means that we need to find the values of lambda and mu such that this given system should not have any solution at all. And the condition for that is, we know the system doesn't possess any solution only if rank of A is not equal to rank of AB. The condition is row of A is not equal to row of AB. And for any such problem, we have to find the augmented matrix in the row echelon form. So augmented matrix, directly writing the augmented matrix, 1, 1, 1, 6, 1, 4, 6, 20, 1, 4, lambda, mu. So this is the augmented matrix. We have to convert this into row echelon form. For that we have to convert this and this element to 0. Now the first row elements as it is 1, 1, 1, 6, and second row element R2 becomes R2 minus R1. Using R1 we have to convert this element to 0. So R2 minus R1, which is 0, 4 minus 1 3, 6 minus 1 5, and 20 minus 6 is 14. Next R3. Again here also it is same 1, so it becomes very simple. So R3 minus R1. So 0, 4 minus 1 3, this becomes lambda minus 1, and this becomes mu minus 6. So as of first we have converted these two elements to 0. Now we have to convert this element to 0. So first two rows, elements of first two rows as it is. 1, 1, 1, 6, 0, 3, 5, 14 as it is, and R3 we have to convert this element to 0 using R2, and here also it is very simple that when we subtract R3 minus R2, this element becomes 0. So R3 is given by R3 minus R2. So this value is 0, this is also 0, and this becomes lambda minus 1 minus 5 is lambda minus 6, and this is mu minus 6 minus 14, which is mu minus 20. So we have derived the row echelon form. Our aim is that row of A should not be equal to row of AB, only then this system doesn't possess any solution at all. So if this value becomes 0, if lambda minus 6 is equal to 0, if this element becomes 0, if this element lambda minus 6 becomes 0, then row of A is given by row of A is nothing but considering this matrix alone, row of A is given by 2, because we know that rank is nothing but a total number of non-zero rows. So row of A is given by 2. Whereas if we consider this mu minus 20 also equal to 0, then row of AB also becomes 2. In that case, row of A is equal to row of AB. But our aim is that row of AB should not be equal to row of A. So in that case, this mu minus 20 should not be equal to 0. Only then row of A is equal to 2, and row of AB, as this element is non-zero, row of AB becomes 3. Row of AB becomes 3. So in that case, row of A is not equal to row of B. For the values that lambda minus 6 is equal to 0 and mu minus 20 not equal to 0. So from these two values, it is very clear that lambda is equal to 6 and mu is not equal to 20. So lambda is equal to 6, mu not equal to 20. This becomes the correct answer. Now let us move on to the next question. The system of linear equation has, again here also we have to check whether the given system has solution or not. If it exists, the number of solutions, either one or many solutions, that is what we have to check. And again here also we have to find the augmented matrix AB, and then we have to convert that into row echelon form, right, considering the augmented matrix directly. So 2, 1, 3, 5, 3, 0, 1, minus 4, 1, 2, 5, 14. Now to convert this into row echelon form, again we have to convert this and this element to 0. In that, first we are going to convert this element to 0. So first row elements as it is R1, R2, R3. First row elements as it is 2, 1, 3, 5 as it is. Second row element R2, I have to convert this element to 0 using this R1 element 2. So only if this 2 becomes minus 3, it is possible to convert this element to 0. So this 2 should become minus 3. Minus 3 is equal to some product into 2, which is R1. So when we divide this by 2 and then when we multiply minus 3, we get this minus 3. So R2 is nothing but R2 minus 3 by 2 R1. Now starting with the first element. First element is 3. 3 minus 3 by 2 into 3, it becomes, into 2, it becomes 0. Now the second element, 0 minus 3 by 2 into 1 is minus 3 by 2. Now the third element, 1 minus 3 by 2 into 3 is equal to minus 9 by 2. So cross multiplication, 2 minus 9, which is minus 7 by 2. Minus 7 by 2. And the fourth element, minus 4. Minus 4 minus 3 by 2 into 5, which is 4 2s are 8, minus 8, minus 15. So minus 23 by 2. Minus 23 by 2. Writing all those values. So 0, 0, minus 3 by 2, minus 7 by 2, minus 23 by 2. Now moving on to R3. R3 here we have 1. So R3, we have to convert this 2 into minus 1. Only then it is possible to convert this as 0. We have 2 here. So this should become minus 1. So minus 1 is equal to product of some element into 2. This 2 is nothing but R1. So here by 2 minus 1. So minus 1 by 2 into R1. So R3 is given by R3 minus 1 by 2 R1. The first element, starting with the first element. First element is 1 minus 1 by 2 into 2, which is 0. Second element, we have 2 here. 2 minus 1 by 2 into 1, which is 4 minus 1, which is 3 by 2. 3 by 2. Third element we have 5 here. 5 minus 1 by 2 into 3, which is 5 2s are 10 minus 3, 7 by 2. 7 by 2. Fourth element, last element, it is 14. 14 minus 1 by 2 into 5, which is 14 into 2 is 28. 28 minus 5 is 23. 23 by 2. Replacing all those values. 0, 3 by 2, 7 by 2, 23 by 2. Our aim is to convert this and this element to 0. As of now, we have converted these two elements to 0, and now we have to convert this element to 0 using R2. So this becomes first 2 rows as it is. 2, 1, 3, 5 and then 0, minus 3 by 2, minus 7 by 2, minus 23 by 2 as it is. And now third row R3. R3 is just, we shall add those two directly. R3 plus R2. So that 0, 0, 0 and again here also it is 0. So finally we have obtained the row echelon form, and when we check the rank of the matrix A, rank of A, to find the rank of A we have to consider only these 3 columns alone. So rank of A is given by, rank is nothing but total number of non-zero rows, which is 2 here. Similarly, rank of AB augmented matrix is also 2 as all the values in the third row is same 0, which means row of A is equal to 2, row of AB is also equals to 2, but it is less than the number of variable 3, because we have 3 variables here, A, B and C, which is less than 3, which means it has infinitely many solutions, because if it is equal to number of variables, then in that case it has unique solution, but here it is less than 3, which means it has infinitely many solution. So this becomes the correct answer. So I hope that this video helps you a lot to understand better about the topic. We shall see further problems in the next video. Thank you.